Okay, so we have electrolytic cells. So let's get started. Which device requires electrical energy to produce a chemical change? That would be an electrolytic cell. Remember, the Voltaic cell is the spontaneous one. So that's the other kind of electrochemical cell. Cell bridge and voltmeter are just parts of the Voltaic cell. An electrolytic cell differs from a voltaic cell because an electrolytic cell generates its own energy from, no, it does not. It requires a battery. So it requires outside energy source, so C or D, for a spontaneous reaction or a non-spontaneous. Well, if you require outside energy, you are not spontaneous, so choice D. Where do reduction and oxidation occur in an electrolytic cell? So, don't you remember the fat red cat ate an anorexic ox? So, red cat, reduction is at the cathode, and anorexic ox. Ox means anode is oxidation. So, reduction is at the cathode and oxidation is at the anode. Which energy conversion must occur in an electrolytic cell? So you start with the battery and then you have your situation going on. So electrical energy to start, and that forms the chemical reaction. Excuse me, not forms, but it helps the chemical energy to get going. Which statement describes electrolysis? So what kind of energy produces what kind of change? Well, you need electricity. So it's not chemical energy and it's not heat energy. So electrical energy from the battery is used to produce that chemical change. Choice C. Here we have electroplating going on. A key being plated with copper in an electrolytic cell. Given the reduction reaction for this cell, where does reduction occur? So remember the fat red cat. So reduction happens at the cathode. So the cathode is the fat red cat, which means it gets larger, larger, larger. So would the key be getting larger, or would the strip of copper be getting larger? It's the key. The key will be coated with the copper. That's the whole point. The strip of copper is just there to transfer to the key itself. In an electrolytic cell, the anode is always, okay. So remember, the anode is negative in a voltaic cell, and so it will be flipped this time. We're forcing it to happen this time. So it's a positive electrode. But remember, anode is always oxidation. So anox still exists. So 7 is D. So remember, it is flipped. It's forced to happen, so that's why it's positive this time. A metal object is to be electroplated with silver. Which set of electrodes should be used? A silver anode and a metal object as the cathode. Okay, so first of all, the metal object needs to get larger. And I'm going to go back up for a second to number 6. The metal object here is going to get larger. So the metal object has to be the cathode. So it can't be this and it can't be this. Yeah. Wait, hold on. Oh, sorry. It can't be C or D. So now I say, all right, which set of electrodes should be used? A silver anode or a platinum anode? Well, if you're going to... This is actually kind of silly. If you're going to be electroplating with silver, you need silver anode, not platinum. For a hot second there, I was like, wait a second. How do I tell? Oh, it's really just a stupid Regents question. All right, here we go. Number 9, which statement best describes the key? So the key is getting larger, larger, larger. So it's the cathode, the fat red cat. And remember, the cathode is normally positive, but we're forcing it to happen in the electrolytic cell, so it would be negatively charged. A. Okay. Which equation represents the half reaction taking place at the fork? So remember, the fork is the fat red cat. Getting larger, larger, larger. So who is gaining electrons? And remember, when you gain electrons, your oxidation number decreases. Okay? So we can get rid of B immediately because that's not a half reaction. And we can also get rid of A because that is not a half reaction either. Half reactions are simply ions to neutral atoms and the gain or loss of electrons. So now we're dealing with C and D. So if we're gaining electrons, our oxidation number goes down. The gain of electrons is part C. See how the electrons are on the reactant side? And notice how we have +1 charge going to 0. So this is +1, this has nothing, so that's 0. So the charge is going down. So it is choice C. All right, 11 and 12. And we got a battery, we got tin, and we've got copper, and we got a switch and all that kind of stuff. In this electrolytic cell, electrode A is designated as the, okay, so A, let's see, hold on. We have we have tin in solution. Tin is solution. So let's just remind ourselves. Fat red cat and anorexic ox. Okay. So if the tin is in solution, that means this is going to keep dumping it in there, which means we're going to have tin 0 becoming tin plus 2. And you'd have to lose 2 electrons, which means we're losing electrons, which means it's oxidation. And oxidation happens at the anode. And remember, the anode is going to be forced to be positive in these cases. When the switch is closed, what will happen to the 2 electrodes? So the tin, A, is going to get smaller, smaller, smaller. So A will dissolve and B will become coated with tin. Yeah, it's choice B. Because if A is dissolving, which is the tin, that's going to be going over there. All right, so another one. What will occur when switch S is closed? So again, the spoon is going to be the fat red cat, getting larger, larger, larger. And the strip of nickel is going to be the anorexic ox, getting smaller, smaller, smaller. So the spoon will gain mass, and the nickel will be... So be careful. Reduction does not mean losing. So that's how they're going to try to get you. Remember, reduction means gain of electrons, and the charge is reduced. So the spoon will gain mass and the nickel will be oxidized. That means loss of electrons. So it's choice D. All right, short answer. State one difference between voltaic cells and electrolytic cells. Include information about both types of cells in your answer. So there's a lot. I think the classic answer is voltaic cells are spontaneous, which means they do not require an outside energy source. And electrolytic is non-spontaneous, and it requires the battery. I think that's probably the classic answer. You could instead say voltaic cells produce chemical energy, and the chemical energy from the voltaic cell produces electrical energy. And I guess I shouldn't really say produces, it should be transforms into electrical energy. Electrical energy requires the battery, so electrical energy converts to chemical energy. Yeah, I'm looking at what the answer key says. Voltaic cells produce energy. Electrolytic cells consume energy. Voltaic cell, yeah. Those are really your two options. You could talk about spontaneity and the energy source, or specifically the kind of energy. But remember, it says you have to include both. So, do that. And also only one. Don't write both the blue and the pink. Just one, okay? Base your answer to the following. You got all this stuff going on. It says, what is the purpose of the battery in this electrolytic cell? To force the non-spontaneous reaction, RxN, to occur. Yeah, because the anode getting smaller, and oxidizing, and the negative electrode, the cathode, getting larger, that's not going to happen unless you have the battery to force that. According to the Regents' short answer key, electrolytic cells require energy, forces, yeah, okay. Okay, the diagram below represents an operating electrolytic cell used to plate silver onto a nickel key. As the cell operates, oxidation occurs at the silver electrode, and the mass of the silver electrode decreases. Just saying, this tells you a lot of information. So maybe if this is a short answer, and earlier in the test there was a question about, what happens to, the mass of something, whatever, use the test to help you answer questions. All right, so it says oxidation occurs at the silver electrode. So this is anorexic ox, which means the key is the fat red cap. So identify the cathode is the key. Yeah, nickel key, nickel. State the purpose of the power source to, again, force the non-spontaneous reaction to occur. All right, another in terms of. Okay, which means you got to talk about both of those in your answer. Explain in terms of silver atoms and silver plus one ions why the mass of the silver electrode decreases as the cell operates. Okay, so this is not the answer. This is just a reaction. So this is what happens. The silver electrode becomes silver plus one, which means it lost an electron. This can guide you to your answer, but this is not the answer. So you can say silver atoms lose electrons and become silver ions, and the mass decreases. So my answer talked about atoms, ions, and why it decreased. Let me read what it says. Silver atoms lose electrons, become silver ions. Some of the atoms become silver ions. Silver atoms are oxidized. Duh. All right, so that's all we got for this. And if you've got questions, let me know. Thanks.